Good day and welcome to today's class. Today's class is a continuation of our previous classes on SS3 Further Mathematics. At the last class, we looked at inequalities. We had done with the first topic, which is on inequalities. And at that class, we were able to achieve the objective that says that we should solve quadratic inequalities and inequalities in 2 dimensions. So I gave you a lot of examples where we looked at linear inequalities as well as quadratic inequalities in one variable, and thereafter we looked at linear and quadratic inequalities in 2 variables. So in today's class, we shall take the second topic, which is on matrices and determinants. So this is said to be the second topic on SS3 Further Mathematics. Now, what are we going to be discussing under matrices and determinants? We shall look at matrices as linear transformations. We shall also look at determinants. What we meant by determinants, you get to know. And thereafter, we shall use that to find the solution of 2 and 3 simultaneous equations. Yes, that is the essence of matrices. Matrices is used in solving solutions of 2 or 3 simultaneous equations, because the much you can do using substitution and elimination method is on 2 simultaneous equations, but from 3 upwards, it is best solved using matrices. So in today's class, under this topic, we shall take the following objectives: that students should be able to, 1, understand the array as linear transformation. By array, we are talking about the arrangement of numbers in rows and columns, which has to do with matrices. 2, we should also find determinants and apply to solve simultaneous equations in 2 or 3 unknowns. So in today's class, I'll show you that we shall look at the first objective, which has to do with to understand the array as linear transformation. So let's look at matrices. That a matrix is a rectangular array of numbers that can be enclosed within braces. Just like I said, array simply means the arrangement of numbers in rows and columns. So these are said to be examples of matrices. We have A, they are arranged in brackets, 2, 3, minus 1, 5, and we have 1, 3, 5. We also have 7, 0, 4, and 5, 1, 3, 2, 4, 4. These are said to be examples of matrices. A matrix, just like we said, is an array of numbers in brackets. Numbers that are arranged horizontally are said to be in rows. So this is said to be row 1, and this is said to be our row 2. While numbers that are arranged in vertical plane are said to be in columns. So this is column 1 and column 2. So we refer to this as a 2 by 2 matrix. So this is said to be a 2 by 2 matrix because it has 2 rows and 2 columns. For this matrix has just a row and 3 columns. So this is row 1. Why this is column 1? I'll call it C1. This is column 2, and this is column 3. So this is said to be a 1 by 3 matrix. This is said to contain only 1 column and 3 rows. This is row 1, this is row 2, and this is row 3. So this is said to be a 3 by 1 matrix because it contains 3 rows and 1 column. While for this, it is said to be, this is row 1, this is row 2, this is column 1, I'll call it C1, column 2, C2, and column 3 as C3. So this is said to be a 2 by 3 matrix because it contains 2 rows and 3 columns. So these are examples of matrices. Now, by notation, a matrix is said to be represented using a capital letter, and most times it is in bold form. For example, this is matrix A, while the element of a matrix is said to be represented using small letters, as indicated in the diagram on the board. So this is said to be element A11, meaning it is occupying, remember I told you this is row 1, row 2, and this is said to be column 1, and this is column 2. So why this is saying to be A11 simply means that this is element A occupying row 1, column 1. And this is said to be A12 representing row 1, column 2, while this is said to be occupying position row 2, column 1, and this is said to be A22, which is row 2, column 2. So these are how elements of a matrix can be represented using notation. Example on notation of a matrix, that if matrix A is equal to this, as we have on the board, that we should find element A21, A31, A23, and A33. So element A21 is said to be, this is row 1, row 2, and row 3, while we have column 1, column 2, and column 3. So A21 means element you can find in row 2, column 1. So when you go to row 2 and column 1, is said to be this. So you can just trace it upwards, and it gives you where these two lines intersect, gives you the element at that point. And this is said to be 5, because 5 is occupying row 2, column 1. Number 2, we said A32. A32 means elements you can find on position row 3, column 2. So this is row 3, and column 2 is here. So our answer is said to be 7. 3, row 2, column 3. If you go to row 2, this is row 2, column 3 is this. So we said it is 4. While number 4, we have A32. A32, that is row 3, column 2, is said to be, okay, A33, sorry. A33, we have row 3, column 3, and that is said to be 2. So this is equal to 2. So for the order of a matrix, how a matrix is being named, a matrix with m rows and n columns is said to have an order of m by n matrix. So we refer to it as m by n matrix. So for example, since we have 3 rows and 3 columns, this is said to be a 3 by 3 square matrix. Why is it called a square matrix? It is called a square matrix because it has equal rows and equal columns.